Hi everyone. In this video I am going to demonstrate how to use MATLAB and do the simulation for single phase control rectifier with RLE load, both converter mode and also the inversion mode. For my simulation I am going to use MATLAB Simulink, selecting a blank model. Firing unit, we are going to use DC firing unit. We are going to connect with the converter. So these two are the terminals we have to connect the input AC voltage. So AC voltage I am selecting here 400 volts peak, 50 hertz supply. Here constant I am going to choose this constant. I can keep the firing angle different values from 0 to 180 degree. Here I can connect my Dmux and visualize the output of my firing unit. So it produces 4 firing pulse. So I'm going to operate in the number of quadrants, 2 quadrant, frequency 50 hertz. So it is a single phase supply. Give OK. Connecting a scope. So the number of inputs is 4. Connect the scope with the mux. Now we can run our simulation for 100 milliseconds. Now we set the firing angle alpha equal to 30 degree. So the firing pulse should be produced after 30 degree. Here we can find, so there is no pulse during the first half cycle. It starts from the second half cycle, negative cycle. So it starts a firing pulse at 30 degree displacement, and it produces that is uniform pulse width. So what is the pulse width we set here for our pulse? That much the pulse that is produced by the firing unit. So this is the negative of cycle. This we have to give it to thyristor, the negative cycle conducting thyristor. These two pulse we have to give to positive cycle conducting thyristor. Now we verify the operation of this firing pulse unit by connecting a single phase fully controlled rectifier. I'm selecting a universal bridge. So it's a 3-phase bridge. I want to select for 2-phase. Here I have to give the firing pulse. Here I have to connect the input voltage to the bridge. Here I have to connect RLC series branch. Now we can connect this as a load. I want to select here RL load 0.5. This is 1000 millihenry load. Here I want to demonstrate the load RLE load. So I connect an RLE load, mean measurement, voltage measurement unit. Here I am connecting here. This is 100 hertz fundamental. The output is double the input frequency. We connect a display unit. Here we have to measure the input power, voltage measurement, current measurement. We have to measure the current, and with the help of this we have to measure the power. What is the power that is flowing between the source and the load? Here I want to measure 50 Hertz, only fundamental. Now we run our simulation. Now we are going to operate our converter in converter mode. In two ways we can operate this converter. One is the converter mode, the other one is inverter mode. From alpha firing angle 0 to 90, we are operating this converter in converter mode. During converter mode of operation, this voltage source value should be lesser than the voltage available here. So now we will run our simulation and check the result. So for 30° alpha, I am getting the DC, it is equal to 220.5. For this case, the power is positive. The power is flowing from source to load side. Now we will operate for a different firing angle and we will check the result. For 45°, for the increasing firing angle, the output voltage is decreasing. Now I'll make it for 90°. For 90°, only the DC voltage is seen here. So the voltage drop here, it is 0. For conversion at 90°, that is voltage is 0. Only the battery voltage is available here. Now we verify our converter in inversion mode. For the alpha 90 to 180°, this converter acts like an inverter. That means the DC source, the load side source, DC source acts as an input. The output is AC. The AC is supplied to the source side. So it acts like an inverter. It converts DC to AC. Now for inversion mode, we should select this value. It should be a reversed one. So the value also should be greater than this total voltage. So now we can run for alpha equal to 135°. So this is the output voltage and the power also reversed in this case load side. Now we can run for 175°. Still it is increasing. The voltage is increasing negative value. Here the power is minus 859. So here 180 is the maximum value. This is the maximum voltage, negative voltage we are getting, and the output of the. From this video we can understand how to use a converter, single phase converter and single phase firing pulse unit to supply a load of RLE a load. If you have any queries, put it in the comment box. Thank you for your time.